Today's lesson, acidity comparison between phenol and acetic acid. In this lesson, we are going to learn from phenol and acetic acid which one is a strong acid and why. So let's get started. Let's see acidic nature of acetic acid and phenol one by one. Structure formula of acetic acid. When it is dissolved in water, then acetic acid molecule releases this hydrogen as proton. Here, this oxygen-hydrogen bond undergoes a heterolytic fission, and as a result, this hydrogen gets freed as proton, and this ion is formed. Its name is acetate ion. As this is weak acid, this acetate ion, conjugate base of acetic acid, combines with this proton again to form this acetic acid. That means this reaction goes backward direction as well. As this is weak acid, equilibrium arrow is used and equilibrium state is established. Now let's see acidic nature of phenol. This is phenol. When it is dissolved in water, then phenol acts as acid in this way. Here, oxygen-hydrogen bond suffers heterolytic fission, and as a result, this hydrogen gets freed as proton, and conjugate base of phenol, that is conjugate base of carbolic acid, is formed, which is this Phenoxide ion. This is also weak acid, so this Phenoxide ion combines with proton to form phenol again, and in this case as well equilibrium is established because these acids are weak acids, acetic acid and carbolic acid. Nevertheless, let's try to know which acid is a strong acid and why. In case of acetic acid, after deprotonation, the ion is acetate ion is this. This acetate ion shows resonance structure, and in this ion, this carbon-oxygen bond is initiator of resonance structure. This carbon-oxygen bond is the initiating point of resonance structure in this way. Here, electronegativity of oxygen is 3.5, carbon is 2.5. Because of the high difference in electronegativity, pi bonded electrons of carbon-oxygen bond move towards oxygen, and here a gap is created between this bond, between this carbon-oxygen bond, and as a result this lone pair turns into bond pair, and this is obtained. Double bond becomes single bond with negative charge, and this single bond becomes double bond. Similarly, these pi bonded electrons move towards oxygen, and this lone pair of electrons turn into bond pair. Again, this ion is obtained. So These are the resonance structures of acetate ion. The hybrid structure of acetate ion is this. Here partially negative charge, on this oxygen as well partially negative charge, and these electrons move continuously from this oxygen to this oxygen. That is, in this case, negative charge disperses between two electronegative atoms, oxygen atoms. That is, in this case, negative charge is firmly bonded to electronegative oxygen atoms. So, this ion gets stability through resonance structures. That is, we can say that a stable ion, because of the resonance structures. And here negative charge disperses between two electronegative oxygen atoms. That is why this negative charge is firmly bonded to oxygen atoms, and acetate ion shows less tendency to combine with proton to form acetic acid again. Now let's see stability of phenoxide ion. Phenoxide ion shows resonance structures in this way. Double bond, here double bond. Lone pair electrons turn into bond pair electrons turn into lone pair. In this way, phenoxide ion shows resonance structures that has been discussed in detail in previous lesson. The hybrid structure is partially negatively charged, partial double bond, here partial bond, partially negative charge at ortho position, partially negative charge at para position, and partially negative charge at ortho position again. In case of phenoxide ion, negative charge over oxygen disperses throughout the ion, that is, from oxygen to carbon of benzene ring. Here the point is scattering of negative charge from oxygen to benzene ring, which is not symmetrical structure, non-equivalent structure. That is not symmetrical. Because of the non-symmetrical structure, this is comparatively less stable. But in case of acetate ion, negative charge disperses between two electronegative oxygen atoms, which is symmetrical structure. Acetate ion is symmetrical structure. Phenoxide ion is not symmetrical structure. Because of the difference in symmetry, acetate ion is stable ion, or this is more stable, and phenoxide ion is less stable. As this is less stable, phenoxide ion has tendency to combine with proton to form phenol again. That is, in this case, equilibrium is established on the most left side. But in this case, equilibrium is established on the left side as it is weak acid, but not like carbolic acid or phenol. Because of the stable ion formation, acetate ion and phenoxide ion, acetic acid is more stable than carbolic acid or phenol. Again, pH of acetic acid is around 2.5 and pH of phenol is around 5.5. We know the lower the pH value, the acid will be stronger. So simply we can say that acetic acid is a stronger acid than carbolic acid or phenol. This is all about acidity comparison between phenol and acetic acid. No more today. Thank you very much.